So, having done the experiment, in the table that I put in the previous video, I'm just going to do one of the calculations here. I'm going to work with metal number 1, which I know is zinc. And these are the numbers that I had. I had the mass of zinc. Of course, at the time I didn't know it was zinc, but I know that the mass of the metal was 64.31. I know that the mass of the water that I used, 59.97 grams. I know the initial water temperature. Well, one more thing, mass of the calorimeter. Which is aluminum. And that was 32.13 grams. And then I had the initial temperature of the water, which is equal to the initial temperature of the calorimeter, which was 21, I believe, 21 degrees C. And I had the initial temperature of the oven, of the metal, and that was 185 degrees C. Now, in the calculation that I did in the class stuff, I was saying we could predict what the final temperature should be, provided that we know we're working with zinc. We could start with this with the specific heat of zinc and have everything we would need to calculate where we think the temperature would end up. But in the experiment, we actually do the experiment, see where it ends up, and the temperature where it ended up. So the equilibrium temperature was 32 degrees. Now, based on all of those, I'm going to do this calculation where sum of all the Q's is equal to 0. And all that is saying is that we're going to have hot metal, cool water, cool calorimeter, and all the thermal energy that's in that system is all going to transfer from the thermal energy from the hot metal is going to transfer into the water and the aluminum, and then everything in that system is going to come to an equilibrium. So I go to do this, and remembering that Q for each one of these is MC times delta T. And what I'm going to do is, using all these input numbers, calculate what I think C is for that metal. So the three terms that I have the calorimeter terms. I have Q of the calorimeter, plus Q of the water, plus Q of the metal, and all those together are going to equal 0. Q of the calorimeter, I have the mass of the calorimeter, 32.13 grams. I have the specific heat of aluminum, which is what the calorimeter is, that's 0.215. I have the temperature change of the calorimeter. It ends up at 32 and started at 21. Those all come from this term. For the water, I have the mass of the water. The mass of the water was 59.97 grams. The C of the water is just 1. And exactly the same temperature change for the water as I have for the calorimeter. And rather than erase that, I'm going to keep going down below here and say plus, I've got the Q of the metal. And the metal, I'm saying, well, I know the mass. The mass was 64.31. The C in this case is what I'm saying I don't know. And I know that this metal started at 185 and went to 32. So now I go through this calculation. Okay, I got 32.13 times 0.215 times 11. So that's 75.99 here. I have 59.97 times 11. So that's 659.7. 0.67. Okay. Go 2 decimal places and I don't really know why I am. Plus, I have 64.31 4.31 times, the difference there is 153, and it's a negative, so I get negative 9839.43 C. So of course I can sum these two and say 659.67 plus 75.99 gives me 735.66. Take this to the other side. Divide by that number. And I get C.075. Now, is that the value C should be? Well, I can look up zinc in the table, and I did that, and I believe the value that I got for the C of zinc, I'll look it up again, but I believe it's 0.093. And so what we see here is, well, not particularly close. I did this calculation, of course, for all of my data, and I got this for zinc. So if I made a table of accepted value and experimental value, and I had zinc, and I had copper, I had brass, I had aluminum, and I had steel. And what I got from the values, I got the accepted of 0.093 here, and I'll double check that in just a second. And I calculated 0.075 for copper, 0.092, and I calculated 0.060 for brass, 0.0925. It seems those are all too much alike there. I got 0.063. And for aluminum, 0.215. I got 0.145. And for steel, 0.113, and I got 0.078. Let me check on those quick.